So kinematics is all about knowing which equation to use. You have those three main equations. It's figuring out which one works best for that problem. So let's give this one a try. So we launch a ball up at 40 meters a second. So we can say that the initial velocity, v naught, is equal to 40 meters per second. The first question wants to know what is the velocity after 3 seconds. So velocity after 3 seconds. Well, we want to use one of our kinematics equations. We launch a ball up. What is the velocity after 3 seconds? So I'm going to turn this back over and look. Okay, what works best? Which equation works best for this question? I'm going to look. Okay, well, I want to know the velocity after 3 seconds. This one works perfectly. I know an initial velocity. I know the acceleration. The acceleration is gravity, negative 9.8. And then I want to know the ending velocity. So if we know that it's 3 seconds, the velocity after 3 seconds, we're going to use v of x is equal to vx naught plus axt. Well, velocity is vx. Vx naught, the initial velocity, is 40 meters a second. We wrote that up here. Is equal to 40 plus acceleration times time. Well, I add, this is a negative 9.8 times the time of 3 seconds. I'm going to round this to 10 just because I'm going to. And we end up with v of x is equal to 40 minus 30. So v of x is 10 meters per second. That is the velocity after 3 seconds, is 10 meters per second. Now, B is going to ask us, what is the position in the air? So we shoot this ball up. What is the position at 3 seconds? I don't know where it is along this curve, but it's going to follow this curve, right? Through time, it's going to follow this curve. It might look like in real life, if you shoot a ball up straight in the air, it's going to look like it's going up. But you have to think about it as a time graph, right? This x-axis right here is time. So as it's going, it's going up and coming back down in a straight line. But through time, it's reaching this point and coming back down to Earth. So that's asking, what is the position at 3 seconds? I don't know where this position is. It could be here, here, here. I don't know. So we have to figure that out. So what equation are we going to use for that? I'm going to flip it back over, look at my equations, and notice that, okay, that one has position in it. I can probably use that one. So I'm going to flip it back over, and we're going to go, okay, well, x is equal to x naught. Well, our x naught is 0. We know that. Plus vx naught plus 1/2 axt squared. Right? So we have x, which is what we're trying to find, is equal to vx naught. Vx naught is 40 plus, vx naught t, my bad. Vx naught t, 40 times 3 plus 1/2 ax t squared. T is 3 squared. We know that ax is 10, or 9.8. I'm going to round to 10, which means that this is 45. If you solve this part, it's 45. You make that negative because it's gravity pushing it down. X is equal to 120 minus 45, which is equal to 75. Now it's 75 meters, right? Where velocity is in units of meters per second. Acceleration is in units of meters per second squared. Those are the differences. Position is in meters, velocity meters per second, acceleration is meters per second squared. So we go and we find the kinematics equation that works. We plug in the numbers. Use gravity. It's pulling down on the velocity. It's holding it down. So it's making the position less. So in that case, this position would have been 120 without gravity holding it down. But with gravity holding it down and bringing it down, it is 75 meters after 3 seconds.